Alright, so today we'll be talking about areas of regular polygons. Okay, first off, an important word is an apothem. Okay, an apothem is the distance from the center to the side perpendicularly. Try saying that 3 times fast. Okay, of a regular object, or just any old kind of object will work. So in other words, if I take it from the center of the object and go to the side and make a perpendicular line, I'm actually making my apothem. Okay, now the formula for the actual area of a regular polygon, is going to be this. So the area, and the polygon has to be regular. So it's 1/2 times apothem times the perimeter, okay, of the object. Okay. All right, so in other words, I need to know all the measurements. Now here's the cool thing, since it is regular, if I know one side, I know all of them, because regular means they're all equidistant and equal angular. Okay. All right, so let's say I know the apothem is actually 5 inches, and one of the sides is 7 inches long. Okay, so there we go. All right, so my formula is going to be set up as 0.5 times 5 times, since we're dealing with the pentagon, there's going to be 5 sides of 7 each. So that's going to be 35. Okay, so we check it out on our calculator. So that is going to turn into 87.5 inches squared. Okay, so something as simple as that. Now, if you don't know, let's say that we did not know, let's get rid of that. We did not know this side and we did not know this side. Okay, so let's go back to try this one again. Now let's say that we know this length right here is actually going to be, okay, let's say that this length is 7 again. Let's say it's 7 inches now, and then this length is going to be, let's say 2 inches right here. Now if this is 2 inches, we know that this is also going to be 2 inches, because it's going to, the apothem actually, since this is a regular shape, is going to perpendicularly bisect the sides. Okay, so that makes that 4. So this actually turns into 0.5 times 7, and since there's 5 of them, times 20. Okay, that is obviously going to turn into 70 inches squared. Okay, so something as simple as that can be actually worked out pretty darn easily. Now, a certain shape that I'm going to show you guys, we're going to actually take a look at it, because there's a certain regular shape that you can actually use a sparse amount of information and actually figure out quite a bit. All right, so let's say that we knew what the apothem was. Let's say it was, let's go 12 root 3. Okay. All right, now you're probably wondering, that's an interesting measurement, and I'm supposed to find the area for this. Okay. Well, the area, you need 0.5 times the apothem times the perimeter. So if you notice, we've got everything but the perimeter. Okay, and we need to know this side. But this is all the information you're given. So technically, that's all the information you need. Because what I'm going to do is I'm going to draw out from the apothem to the edge, and this is going to be the radius. Okay, the radius goes out to the the vertex. Okay. All right, now if this length right here is 12 root 3, what you want to do is you want to draw it off to the side, because you can actually work with it a lot easier if you just think about it in terms of its triangularity. Okay, we know it's a right triangle. Alright, so it's pretty simple like that. Alright, now here's the cool thing, is that if I actually repeat drawing that triangle, I'm going to have 1, 2, 3, 4, 5, 6. I'm going to actually have 6 triangles. Okay, now if you remember, the central angle inside of any kind of shape is going to be 360 degrees. So if I have 6 of those, so that's 360 degrees divided by 6 triangles, that means that top angle is going to be 60 degrees in each. Okay, now that means that this whole thing right here, let me change color. That means that this whole thing is 60 degrees. So if I'm doing half of that, that means that that's 30. So this is 30. This is 90. Bet you can guess what this is. This is 60. All right, so now I'm dealing with a 30, 60, 90 triangle, okay, which we all know is definitely dealing with special right triangles. So if this is 12 root 3, that means that this is 12 and this is 24. But we don't need the 24 unless we wanted to, unless they specifically asked you the radius. Okay? Alright, so what we need is just the 12 right here. Why is that? Because this 12 right here and this 12 right here make up one side. Okay, and since there's 6 sides, 6 times 24 is going to be my perimeter. So I'm going to have 0.5 times the apothem, which is 12 root 3 times, let me see, it's going to be 6 times 24. Okay, and you can seriously just put this all into the calculator and be able to get this. Now, I know in the past I've shown you guys proofs of how to find where these formulas come from, but to be honest, this one's a little bit more complicated than what I would like. So, for right now, just accept the fact that the formula for a regular polygon is just going to be something simple, straightforward as 1/2 times perimeter times the apothem. Okay. All right, and this actually turns out to be a really cool number, 1496. And let me see, what was it, inches? Yeah, let's put inches. Square inches. Now this is obviously an approximation. It should be 1496.492. Okay, square inches. All right, and obviously this is definitely going to be an approximation because we're not getting the exact answer. Okay, but as you guys can see is that, and this only works on a regular hexagon. Okay, so if we were doing any other type of shape, we would not use this formula because it doesn't arrive to the nice 30, 60, 90 triangles that we need to use for special right triangles. Okay, the only other shape that actually does that is the square, but the square, all you need to do is find one of the sides and just work with it that way. Okay, all right, that is it for working with areas of regular polygons. I'll talk to you later. Bye.